So let's get started. Corbin, thank you for joining me today. It is so great to have you here with us. Now, some of our viewers may not be familiar with you and your company. So could you start by telling us a little bit about your background and your work at Weldment Design?
Thank you, Stephanie. Yes, so I started out in the steel industry due to my family's company. They had a steel fabrication company that was created back in 1962, actually sold in 2023. But I started off as a fabrication apprentice, which kind of gave me, I think, my slightly different approach into engineering. My father was the one who was in charge of all fabrication and heavy moves, and so they would be moving these multi-million pound barges and large steel structures. And I was really just amazed by this. I wanted to understand really how it was done. And so that really pushed me into engineering and, followed the classical approach. I actually had a mechanical engineering degree initially, and then got my PE in 2018, created Weldment Design in 2019. Since then, our main focus really has been supporting fabricators, just like what my family's company was. I saw some of the headaches that they had in fabrication, and I wanted, to be the engineer to kind of help fix that. So ultimately, my goal has been to provide outsourced engineering services to these fabrication companies to really help them achieve the goals that they're trying to get to. And now I oversee approximately 20 engineers and detailers combined between both my company, and we also have a partnering firm by the name of 2096, where we handle all types of steel structural engineering and various different manufacturing support.
So it is impressive to see how your hands-on fabrication experience has shaped your engineering career. The perspective has been incredibly valuable for you, I imagine. Now, your company focuses on designing and engineering welded steel structures for some of the most challenging industries like defense, mining, engineering, and even manufacturing. What role do you specifically play when a project is brought to you?
This really depends on the specific project. Ultimately depends on when our customers are really coming to us. We're not really that classical structural engineering company where our primary clients are necessarily architects. Since we focus on those fabricators, fabricators needs to truly get the job done. We really have to help them to get down to the nuts and the bolts. So sometimes this is like a turnkey package where somebody's coming to us, they just have a napkin sketch and they want us to provide everything from shop drawings, construction support. Other times we're brought in a little bit more of an urgent situation where, we're kind of coming to fill some gaps there at the end of the project. And, they ultimately need an engineer to help them get over, there may be some form of delegated design like these connections that they're coming to us for.
Now tell me why you chose to support these type of operations that inevitably must be stressful and chaotic.
Oh, I really think that, we want our customers to see us like a team member, not just necessarily some outsourced commodity. And so in order for us to do this, we have to really be there for them, really no matter what. Nowadays, we find more and more that, these fabricators are being forced to do things that they haven't commonly had to do. They're basically being delegated things like these connection designs where your EORs are kind of making them do the catch-all. So, we're now even seeing that this delegation is going on to our steel detailers who are now coming to us with these for these same kind of reasons. These detailers are identifying that, hey, there's a gap and they need an engineer to come and seal off on the design so that this building can go together. So.
And when you think of your entire portfolio of work, what would you say the percentage is that focuses on connection design?
I mean, honestly, it's relatively low for us currently. I mean, it's been more 5 to 10%, but these requests are actually increasing quite rapidly as kind of word gets around about what we're able to provide our customers. But much of this growth and success, I do contribute to us investing in these right tools, much like IDEA StatiCa, because these tools are really helping complement our skill sets and then showing our customers what we could do. So that connection design market is growing very quickly for us.
Then can you tell me a bit about the workflow associated with delegated connection design? Is it something that allows you to be part of a project from the onset?
Um, I kind of wish it always would, but unfortunately, there's quite a bit of times we're kind of brought in at the very end of the game as the buzzer's going off. We find that commonly EORs are adding in those boilerplate statements to their designs that are a little bit of a catch-all for anything that may not be completed in detailings. Many of the times, this is something like any shear and moment connections not shown shall be the responsibility of the fabricator, or double angle shear connections are required throughout, and any deviation from these connections go onto the fabricator for them to ultimately design that deviation. This then makes it where, at that bid stage, they kind of just throw out a number, and then at the final stages of design, whenever you're getting into that approval, people like the steel detailers are coming in and saying, hey, we've got 10 connections that really haven't been detailed by the EOR fabricator. You're responsible for this. We need an engineer. So.
Now, when you're working on these types of projects, who do you get your inputs from?
It really depends on the client, honestly. Some are a little bit more prepared. They will, the project managers and the estimators actually will reach out to us. They've kind of been burned in the past, and so they realize, hey, we've got a couple $1,000s of engineering scope at the end of this. We need to make sure we get in front of this. And then, obviously, if I'm changing things at the end, that's a huge cost to them too. But there's then some of these other kind of more other fabricators that are kind of coming in at the end. Again, they just don't really know, so they're coming in, and it's going to end up being more the steel detailers that are kind of reaching out to us because the fabricators weren't completely aware of the requirements, and so those are the ones that are now coming to us to get them to help them through the gap. They can put a good design together, but ultimately you have to have that science behind it and the math that really proves that these connections work. So.
So it sounds like you're saying you're almost seeing a bit of a shift in the communication path from the fabricators to the detailers. So what do you think is causing that shift?
I mean, I've seen both sides of this coin. I've been a part of the teams and helped design buildings in the past as well. And so, I believe that these EORs ultimately they're being pushed to a permit set, and there's this mentality that you can just catch everything in the shops. So the fabricators really have nothing really to quote off of until that steel detailer starts digging into the model, and no one on the fabrication side really knows where the deviations are required from the EOR structural sets. So the detailers now are forced into that role again of designing these connections, but there are very clear stipulations about structural design components. You must be a PE in these states to approve these structural designs. This is then leading them to teams like mine, who is going to really work with their existing details and what the fabricator already really needs to hopefully minimize these changes. And when it comes to these complex moment connections, it can be difficult to create a cost-effective solution, especially if you don't really have the math and the tools behind you to say, yes, this definitively works.
So every project varies and every workflow varies. And it feels like there can be many ways that things can kind of get lost in the mix. So where do you see some data insufficiencies or traps in the workflow?
Personally, I think it kind of starts with the disconnect between architects and owners, just to put it more in the AEC world, and the EOR. So not everybody's really using the same systems and the same models. Some people have Revits, and some people are using PDFs. I use SolidWorks, SDS2, whatever. Everybody's using these different tools, and the fabricators then come in. They have their own sets of tools, and they're saying, and so there's just this huge disconnect between the two. The only true thing that you really have are the PDF files or the drawings. But there's typically gaps created in that due to the boilerplate notes and the typical details. Now, granted, I understand why those are there, because you can't, a lot of times these EORs aren't necessarily contracted to design to that level of detail. But I don't know, maybe it's just like my millennial mindset. I started doing 3D modeling in 9th grade, and I'm just kind of wondering why we can't all have the same model. Why can't we all just really be talking from the same place? And I think that we would relieve a lot of our problems.
So I love your answer because I think you've just hit on a real core issue, right? The industry isn't at a single shared model yet. But at IDEA StatiCa, we strive to deliver tools that are moving us closer. Because it integrates with the major platforms, it allows teams to pull the relevant geometry and loading into one environment. It's really not about forcing everyone on the same software. It's about enabling smarter collaboration with the tools that you already have. So let's pivot a bit. You've recently completed an exciting industrial pipe rack project. Can you tell me about the project?
Yes. So I've kind of highlighted some of these complexities in connection design and disconnected teams, but truthfully, this opportunity specifically, the team really was almost flawless. I mean, the communication was there. They did need it fast though, and that's just kind of a part of the industry. It was needed fast, but the streamlined communication, the way that all parties work together, really ended up helping this be a very streamlined project. The structure was designed by Hatch as the EOR. It was fabricated by a company called St. George Steel, a very loyal client of Weldment Designs. And then it was detailed by a steel detailing company called Cronus Steel Detailing, also a very close collaborator with Weldment Design. Together, this team, they really pulled off a pretty amazing feat where they've nearly completed almost 800 linear feet of fabricated pipe rack structures. And these are 28-foot tall, again, almost 800 linear feet of these for a magnet manufacturing plant that's in Oklahoma. So, in about mid-August, we were contacted by St. George Steel to support the detailing team with Cronus for the approval of these delegated connection designs. Hatch provided a very clear specification to follow that outlined both the moment and the shear requirements of each of these beams. We were awarded the contract that first week of September, so it was a pretty quick turnaround. And then within days, Cronus Steel, as detailer, provided us these updated erection drawings. But even more valuable, at least for us, they also gave us these IFC models. So we're able to take these drawings, we're able to take these models, and then from that, we're able to then analyze what they've already put together. Cronus had already worked with St. George Steel and made sure that this is what the fabricator really wanted. So we're really taking their ideas and then we're trying to prove it worked. Whenever we then kind of got together, we did identify those very critical details. We want to group as many of these things as possible, and then we began our analysis. About 2 weeks later, we were making some minor tweaks in the design based on our findings, and using IDEA StatiCa to help present that to the team. And then the following week, we were sealing drawings. So about 3-week turnaround for the full analysis of 4 different phases of these pipe rack designs.
It did move pretty quickly. Now, can you tell me more about the connection design itself for this project? What kind of challenges did you face?
So with this specific one, there was a lot of pretty tight spacing. The member sizes weren't very large, and because of that, it made it where we really had a little bit of an accessibility issue. St. George Steel wanted extended shear tabs, while the EOR kind of had a default of double angles. Double angles are much more conservative, reliable stance, while the extended shear tabs they can induce some moments into these columns. So by doing that, they had initial size of those shear tabs, and we were able to run the numbers. Luckily, we didn't find major changes, but whenever we dug into it, we did find, hey, actually your shear tabs need to be a little bit larger in these scenarios, and we needed repads on the back where these shear tabs were connecting to the webs due to the limit state that was ultimately governing that and wanting to kind of fail that web from that shear connection. But after that, though, we were able to pretty quickly explain that story. Cronus was able to update the details, and then we were able to provide the report. No comments on the report were received. I mean, they accepted it, but there was no rejections. It was all very clear and straightforward, and kind of a first pass try. So.
Right. And when you have all the pieces of the project completed, what kind of outputs are expected? And how do you share your analysis?
So, historically, we've done really more of just kind of a red line, and there would be quite a bit of back and forth. We've now got to the point where we will share our IDEA StatiCa models, every connection using the viewers that IDEA StatiCa has. And what's really nice about those viewers is that persons can then pull out the IFC models, they can pull out DWGs, really. Between the two of those, typically persons can then pull all the information they need. They can even dig in and find the weld sizing, so we can make sure that we are talking apples to apples. They can take that IFC model, drop it directly into their model, whether that be SDS or et cetera, and see the overlay, see if everything's matching up. So, that's a good way of how we ultimately end up sharing that information. And then we'll also use just pictorials. We'll take our IDEA static model and we will show pictures of our results and ultimately help communicate that way. Seeing things in 3D, again, in my mind, is a little bit easier sometimes than trying to thumb through 10 different pages of details. So.
I agree. The added of picture tells 1,000 words couldn't be more true. So you've talked a little bit about our reports and sharing the design diagrams or whatnot. How do you feel like IDEA StatiCa might be helping you to educate the industry and the people that you work with?
Well, the shear tab example is kind of a prime one. So, you as an engineer, we do have to recognize who we're talking to, and I can't go to a fabricator and start talking about von Mises stresses and failure criterions. They're going to look at me like with their eyes crossed. So, but what's great about this is that everybody can tell what red and blue mean. Red fails,
Mhm.
blue doesn't. And so I can very quickly show personnel that maybe don't have that engineering background that, hey, this is failing, you can see where it's failing, this is our weak point, how can we fix that? They can then come in and say, well, we've done it this way and we've done it that way, how about this? And then we can work back and forth together to get that good effective solution. On the other end of the spectrum, when it comes to the engineers, though, you have reports that are sitting there producing actual calculations that tie back to AISC codes. So you can dig into these codes, you can validate it, you can learn from the codes as you're doing this, and I can tweak things. I can move this, see how the numbers move, and you can use that to help educate people as to, learn a little bit more about these limit states and why these things are actually failing. So it really helps educate both sides of the spectrum.
So it is personally thrilling for me to hear you say this, right? You might be familiar with our tagline, calculate yesterday's estimates, which really reflects our mission to replace that guesswork with precision, right? Empowering engineers to make confident, code compliant decisions. And what you have just described is truly that mission playing out in real world. So thank you. And I welcome you to be honest. How has it been working with IDEA StatiCa?
I mean, the reason I came to IDEA StatiCa is because I typically get the weird ones, so to speak. It's not your common connections a lot of times. So I needed a tool that I could build almost anything that I wanted, and IDEA StatiCa really created that some bit of a limitless possibilities in this. And admittedly, the software isn't the easiest to learn, and I've used a lot of softwares, but at the same time, it really shouldn't be. This is a very advanced tool. There's a lot going on here, and this is a tool meant for engineers. So that learning curve's to be expected, and you really have to understand the science of this to really use it effectively. You have to be able to do these force balances. So that's probably the hardest part, but again, it's understandable from an engineering tool. The best part though is that when I get stuck, I'll call Andrea or John or Johan or any of them, and they will help me. They're basically on call from day one. So I've had abundant amount of support between them, and then you have all these educational resources too that really help educate me as well. There's a great page on limit states actually that y'all have created that I've studied and studied and studied. So overall, it's been a great experience.
Oh, that's wonderful to hear. Now, what recommendation would you make for someone who's looking to get into connection design?
Go back to the basics. So, in order to do this, you need to understand where these moments and these shears are coming from. You need to understand that force balance. You need to understand the equilibrium requirements of connection designs, and you need to understand the limit states. Why are these things failing? So, IDEA Statica can really help you, put a picture to this and help you run those numbers, but you really need to understand what IDEA Statica is doing and what it's proving. So, you're going to be pressured to make really big decisions, and a lot of times it's going to be that you have to do it really fast. So, you really want those tools to be in place. You don't want to be trying to reinvent the wheel when you get that first PO. So, make sure you have all of that. But, once you do, you will really gain respect for what this industry does day in and day out, and what we have to do to really make sure that the public stays safe.
Great, thank you. Corbin, I want to congratulate you on this project and your business growth, and thank you for joining us today.
Thank you for having me, Stephanie. And I look forward to our continued collaboration with IDEA Statica.